Today we're going to be talking about comparing rational numbers. So a rational number is any number that can be written as a fraction. Okay, so basically negative numbers, positive numbers can have terminating and repeating decimals included in there. So versus integers, we're just kind of your counting numbers. 1, 2, 3, 4, -1, -2, -3, -4. Now we're adding in fractions and decimals. So steps to comparing two rational numbers. The first thing that we're going to ask you to do is look at the numbers and ask yourself these two questions. Are the signs different? Positive versus negative, because we should remember positive numbers are always greater than negative numbers. And then are the whole numbers different? Because if the whole numbers are different, then you don't need to look at the decimal or fraction part of it. If you've done that and neither of those is true, then we're going to move on to step 2. If the signs and or the whole numbers are the same, we're going to turn every number into a decimal. Once we turn it into a decimal, if they don't have the same number of decimal values, we need to add zeros to the right of the last digit so there are the same number of decimal places in each number. After that, we can compare. So, compare the following numbers and show work to prove answers. Even some of those that you don't actually need to do calculations for, we want you showing or explaining why the one is greater than the other or equal to the other, okay? So for this one, when we're comparing, the first thing I'm asking myself is, are the signs different? So in this one, we have a negative and a positive, so the signs are different. So my work is going to be here that the first number is negative, the second number is positive, okay? So what we should know is that a negative number is always going to be less than a positive number. So for the inequality, we don't have to look at the decimals at all. We're just saying that negative 3.35 is less than 3.25 because it's a negative number. Number 2, again, first question I'm asking myself, are the signs different? So this first number is positive, this second number is negative. Yes, they are different. So my work here is going to be that we have a positive number and we have a negative number, okay? A positive number is always going to be greater than a negative number. So our inequality should be that 5/8 is greater than negative 7/12. Did not have to do any calculations. All right, number 2, again, the first thing we ask ourselves, are the signs different? We have a positive and a positive, so nope, they're the same. Second question we're asking ourselves, are the whole numbers different? Well, this one here, our whole number is 2. Right here, there's not a whole number, so the whole number is 0. So we have 2 and 0. Are they different? Yeah. So we actually don't need to look at the fractional part. We're just going to look at the whole number part. We have a whole number of 2, and here we have the whole number of 0. That's all I need to compare, because the fractions really don't matter anymore. So 2 is greater than 0. So that means that 2 and 5/6 is greater than 3/12. Which means the inequality sign is 2 and 5/6 is greater than 3/12. Then here, again, we're going to look, are the signs different? We've got a negative and a negative. Nope, they're the same. So next thing is we're looking at the whole numbers. We've got negative 5 and negative 3. So that whole number is different. I don't need to look at the decimal part. I don't need to line them up. So we've got negative 5 and negative 3. So now we got to be careful. Remember, negatives work in the opposite way. Normally, if there weren't negatives, 5 would be bigger than 3. But for negatives, it's the opposite. Bigger negatives are smaller numbers, so negative 5 is actually less than. It's further to the left than negative 3. So our inequality sign is negative 5/8 is less than negative 3.841. All right, so those were some examples where we didn't have to do as many calculations. Now we're going to look at some where we do have to do that. So right now when we look at this, they look the same, but the key difference here is that repeating bar line. What that means is this is 0.3 followed by a bunch of 3's versus this is 0.3 followed by a bunch of 0's. So the work that we're going to do is I'm going to write at least one more number here. We'll see if we need to write more. So this means 0.33 versus the second one means 0.3 followed by a 0. Okay? So they have the same whole number. They're both positive. So we're really just looking after the decimal. 33 is bigger than 30. So 0.3 repeating is greater than 0.3. Number 6. Okay, are they the same sign? Yes. Do they have the same whole number? Yes. So now we have to look at the decimals. They're both decimals already, but they don't have the same number of decimal values. This has 1, 2, 3. This only has 2, so we're going to need to add a 0 there. So our work is just going to be rewriting these so they have the same number of decimal values. So, since the whole numbers are the same, we only need to look at that decimal value. So 734 compared to 730. If they weren't negatives, 734 is bigger than 730, but since it's negative, it's the opposite. It's actually less than. A bigger negative is actually a smaller number. So negative 2.734 is less than negative 2.73. All right, number 7, 3/4 and 0.7. So first off, are they both the same sign? Yep, they're both positive. Second off, do they have the same whole number? Well, there's nothing here, which means the whole number is 0 and 0. Yep, they have the same whole number. So now we got to convert them both to decimals. This guy right here is already a decimal. But 3/4 we need to convert to a decimal. So I'm going to use my conversion chart. I'm going to find 3/4 right here. The equivalent decimal is 0.75. So 0.75. All right, so now I need to look and make sure they have the same number of values after the decimal point. We've got 1, 2 here. We only have 1 here, so I need to have a second value, so I'm going to add a 0 in there. So now we're looking at, we got positive values, so it works normally. 75 is bigger than 70, so it is greater than 0.7. So 3/4 is greater than 0.7. All right, next one. Do they both have the same sign? Yep, they're both positive. Do they have the same whole number? Yes, it's both 0. So our work is convert them to decimals. They're already decimals. But we need to make sure they have the same number of decimal values. There's 1 decimal value on the left, there's 2 on the right. So on the left, I'm going to add a 0, so they both have 2 numbers to the right of the decimal. So if I look at this, it's positive, it works normally. So 80 is smaller than 87. So 8.8 is less than 0.87. Number 9. Negative 2/3 and negative 5/6. Are they both negative? Yes. Do they have the same whole number? Yeah, there's no whole number, so the whole number is 0. So we need to convert. So again, I'm going to use my conversion chart. 2/3. Find it over here. 2/3 is 0.6 repeating. Remember, that's 0.6 followed by a bunch of 6's, not zeros. So negative 0.6. I'm going to show that it's repeating in case I need to add values. And then negative 5/6. So looking at 6th. 5/6 is 0.83 repeating. That 3 repeats. So I'm going to write negative 0.83 with the repeating bar there. So for this guy, we only have 1 value after the decimal written down. Here we have 2. So I need to add a second value here. It's not going to be a 0 because it's not 6 followed by a bunch of zeros. It's 6 repeating, so it's followed by another 6. Okay? So now we need to remember we're talking about negative values here. Okay? So if I kind of ignored this, normally 66 is less than 83, but since it's negative, it works the opposite way. Negative 0.66 is going to be greater than 0.83. Number 10, negative 6.05 and negative 6 1/2. They have the same sign, they have the same whole number. We need to convert to make them both decimals. This first one is already a decimal. This second one is not. So 1/2, using my conversion chart, is equal to 0.5. So we have negative 6.5. The number on the left has 2 decimal values. The number on the right only has 1, so I need to add a 0. So remember, we're looking at negative, so it works the reverse way. Normally, 5 would be less than 50, but since it's negative, it's the reverse. It's going to be greater than. All right, so make sure you're being really, really careful using your conversion chart to do the conversions, and being careful with negatives. Remember, they work the opposite way. Go ahead and do these 2 U tries on your own.